So some of you asked me to kind of give you a summary of what we've been going over. So here's what we've covered so far. So we talked about the standard position of a function. And so position. So a standard position of an angle of rotation is going to have to follow this conditions. The theta's got to be between 0 degrees and 360, meaning that you can't go past a rotation. If you're dealing with radians, then theta has to be between 0 and 2 pi. So if I were to give you an angle of rotation, which always starts on the positive x-axis, no matter what direction you go, if I were to give you something that landed in, let's say, quadrant 4, that would be considered standard position because it's a positive angle, and it has to be positive, right? It has to go counterclockwise. It's a positive angle. It's less than a full rotation, and so it's in standard position. Now, if I started at the positive x and this time went this direction, that's a negative angle hitting the same terminal side, and that is not in standard position. 1, because it's a negative angle, okay? And 2, because it's actually less than 0. And remember, for it to be in standard position, it's got to be greater than or equal to 0. Okay, so that's standard position. We also talked about coterminal angles, which it just so happens that I have one right there on the screen, coterminal angles. So I started on the positive x-axis, like I always do, and I continued to, or I went in a clockwise direction, and I hit the terminal side of the original angle of rotation that I was working with. Because they share the same terminal side, that would be a coterminal angle. So let's go ahead and put some numbers to this. So let's say the first one, the original one that I had, was theta equals, let's make that 100. Let's see, it'll have to be 180, past 180. So let's say 200. Okay, I don't know where I'm making it up. Let's say that's 200. And then remember that I also just gave you this angle, which goes from the positive x to the same terminal side. So if from the initial, from the positive x-axis counterclockwise to the terminal side is 200, then what would this remaining negative be? And so what I would tell you to do is to take 360 and subtract 200 from it, okay? I'm gonna write it vertically. So minus 200, which is going to give you 160 degrees. So a coterminal angle would be negative 160 degrees. The thing about coterminal angles is they don't have to, there's not just one, there's an infinite number. So if I wanted to, I could have, instead of stopping at that terminal angle, I could have went around and I could have gone past a rotation, okay, and hit that again. A coterminal angle doesn't have to be in standard position, okay? If I did that, then what I would have done is I would have taken 360, okay, and added 160 to it, even though I know I'm going a negative direction, and that would have given me 0 to 520 degrees. Hopefully I'm not wrong. And so another coterminal would have been negative 520 degrees, okay? Now you could also go in a positive direction. And if you chose to do that, then you would have still, and this is being repeated over and over, you still would have had to start on the positive x and go all the way around. And you cannot stop here because that's the original 200. So I would have had to go one revolution, come back around, and then hit it again. So in this case, I would have had 360 plus 200. And so 360 plus 200 would give me 560. So a positive coterminal angle would have been 560, okay? So you had standard position, you had coterminal angles, and then we talked about reference angles, okay? And we had 2 special right triangles, and so we have to remember those. So what I want to do is I want to go ahead and write those out, okay? So I'm going to just draw a right triangle, 2 of them actually. And I need for you guys you have to know these. So I'm going to make this one a 30, 60, 90. So I'm going to place 30 here, but placement isn't what matters. It's the side lengths. You have to know what those are. This will be my 45, 45, 90 triangle. Across from 60 is going to be a length of the square root of 3. Now, the side across from 60 is also the side adjacent to 30, so just keep that in mind. The length across from 30 is going to be 1, which is also adjacent to 60, and the hypotenuse of the right triangle is going to be 2. For 45, 45, 90, the length across from 45 is 1, and this one would have to be the same because they're equivalent angles, so the sides will be equivalent as well. Okay, and then the hypotenuse is the square root of 2. You can use the Pythagorean theorem to verify that those are in fact the hypotenuse. Okay, so we need to know these because a lot of times your reference angles are going to be some form of one of these triangles. So a reference triangle is going to help us when we have something like this. If I gave you an angle of rotation, a theta, that was in, let's go ahead and say quadrant 3. Okay. And let's go ahead and also find out what that would be. So I want to give you a good one. Let's see. Okay, so let me give you 225. So right now, theta is 225 degrees. Here's my terminal side. Here's that point that I'm going to over exaggerate. That's what I get whenever I extend that terminal side. And remember, there's this big circle where we're going to end up having a triangle in. From that point that I over exaggerated, I'm going to draw a perpendicular line that connects to the x-axis. And if you look, there's my right triangle. Okay. Now let's look for the reference angle. Remember, the reference angle is going to be between the terminal side of your reference angle and the x-axis. So what I'm going to do is I'm going to take 225, the whole angle, and I'm going to subtract 180 from it, because if I subtract 180 from it, what I'm left with is this angle right here. Okay. All right. So let's go ahead and do that. So if we do that, we're going to end up with 45. So I now have a reference of 45 degrees. A reference angle, no matter what direction you go, is always positive. Okay. And it's always connected to the x-axis. So it's either going to be sitting on top of the x-axis, like these two dotted triangles that I have, or it'll be hanging from the x-axis. So it kind of looks like a bow tie. Well, since that's a special right triangle, and this is the exaggerated point, see that reference angle is the same point in the same location as 225 degrees, which means that if I find the sides of this triangle, which are -1, -1, and root 2, I will have the same ratios as 225 because it's in the exact same location. That's why I can use the reference angles. By the way, the reason why these are negative is because here's the origin, right? Don't forget your algebra part. You're on the origin. I'm to the left of the origin, which means my x is negative. I'm under the x-axis, which means my y is negative. So remember, these are my y and my x axes. All right, so the reference angle would help you to find certain things. So if I ask you, hey, what's the sine of 225 degrees? Then you would actually be able to say, okay, sine, I'm going to use my reference angle because I can't find the sine of 225 being obtuse, so I have to use its reference angle, which is what I just drew. That would be opposite over hypotenuse, which is -1 over square root of 2. And then just to kind of review, you would have to rationalize that denominator, which would give you -√2 over 2. And for those of you who are forgetting, I had to multiply by a form of 1. And remember, this is when we multiplied by √2 over √2. Okay? So I'm hoping that helped. So you had to know like where to put these triangles in order to be able to evaluate certain things, expressions and things like that. So I think what I gave you, and I don't know if this is clearing up what you guys wanted. But one of the examples that we talked about was this. For theta equal to 5 pi over 4, right? Evaluate cosecant theta, cosine theta, and then cotangent theta. And so the very first thing that you want to do is you want to draw your x and your y, or excuse me, your y and your x axes, okay? And you want to go ahead and you want to identify that your denominator is fourths. And so therefore, I'm going to take the top half of the quadrants 1 and 2, the top half. I'm going to divide that whole half, which would be a half circle, right, into 4 parts. So 1, 2, 3, 4, okay? And then what I do at the top, I'm going to do the bottom. So this bottom half gets divided into 4 parts as well. So now I can go ahead and label. Now we know that this is 0 radians. This from here to here is 1/4 of my parts. So what I'm going to do is I'm going to label that 1 pi over 4. This would be 2 pi over 4. This would be 3 pi over 4. This is 4 pi over 4. 5 pi over 4, 6 pi over 4, 7 pi over 4, and then also 8 pi over 4. I didn't bother reducing because I just wanted to see the parts, right? I want theta equals 5 pi over 4, and so therefore I'm going to go ahead and start at the positive x-axis like we've been doing. Start here. I'm going to go around clockwise because it's positive until I hit 5 pi over 4, and there it is. That's theta. I mean, if you look, right, theta is creating, it's an obtuse angle. It goes from here to here. Look at that. That is a huge angle, right, compared to an acute. And so what we want to do then is we want to overemphasize this point right here. And what I want to do now is I want to draw that perpendicular line from that point to the x-axis, and I'm going to use this reference angle. So what I want you to understand is this. If from here to here is 5 pi over 4, right? And this from the initial x-axis, right, to this line is 4 pi over 4. If I subtract the blue from the red, what am I left with? Because that's my reference angle, right? And I'm left with pi over 4. And that's what I want you guys to get used to. So when you were converting, you remember when we did the quizzes, I said, hey, you've put a star by this because you're going to need to know it. Pi over 4 is equivalent to 45 degrees. And that's how I know I have a special right triangle. So pi over 4 is equivalent to 45, which means across from it is -1. Adjacent to it is -1. And the hypotenuse is square root of 2. So now I can actually evaluate cosecant theta, which by the way is hypotenuse over opposite, which is the same thing as, and we went over this, r for the radius, which is the hypotenuse, over y, because y is opposite of your theta. And so now I'm going to plug those numbers in. The radius is the square root of 2. Across, or opposite, from pi over 4 is -1. So square root of 2 over -1 is equivalent to -√2. Okay? And just in case you need to see all of them, let me go ahead and do cosine theta. So cosine theta is adjacent over hypotenuse, or x over r. Your x value is -1. Your radius is √2. You're going to have to rationalize that denominator, multiply by √2 over √2, and you get a final value of -√2 over 2. And last, cotangent theta, which is opposite over adjacent. No, it's not. Cotangent is actually adjacent over opposite, or x over y, okay? My x value is -1. My y value is -1. And a negative divided by negative is positive, so that is what we're going to get, okay? I hope that helped as a summary. Let me know, please let me know if you have any additional questions. I would love to answer your questions if I can.